Today I'm going to be teaching you how to solve a system of equations problem using elimination. When solving an elimination problem, your first step is to arrange the equation with like terms in columns. They must have the same variable and have opposite coefficients in the two equations in order to eliminate. So take number 3. In order to solve this, I would first organize my terms into columns where my variables would line up. So I'd take the first equation and then rewrite the second equation where I have a column of x's, a column of y's, and a column of constants. Okay, I want to line up my variables so I can determine which variables will cancel out. So I'm looking at these as if they're in columns. And I'm going to eliminate these by adding each column. So as you can see, my first column, negative 5x plus 5x, is going to cancel out. So I'm going to eliminate this, and this gives me 0. For the second column, 1y minus 2y is going to give me negative 1y. And 8 plus 2, because both of these are positive, is going to give me 10. So next I can solve my problem by isolating the y variable and dividing by negative 1 on both sides. When I divide negative 1 and 10, I'll get negative 10. My answer for y is negative 10. Each system of equation problem should give you a set of coordinates or x and y value that is a solution for both equations. So far I have my y value, and now I'm looking for my x value. To find my x value, I have to take my y value, which is negative 10, and plug it into one of these equations. I'm going to pick the second equation because it doesn't have a negative. It seems like the easiest equation to use. So I'm going to come down here, I'm going to write 5x minus 2y equals 2, and I'm going to plug in what I found to be my y value. I'm going to plug in for y to find my x value. So instead of y, I'm now going to write negative 10. And I'm going to solve this equation for x to determine the x value. Negative 2 times negative 10 is going to give me a positive 20. And I'm going to isolate x by subtracting 20 from both sides. This is going to leave me with 5x on this side and negative 18 on the other side. And then I can isolate x by dividing by 5 on both sides. So my answer, I get x equals negative 18 over 5. And since we're talking about a set of coordinates, I would want to divide negative 18 by 5 to be able to plot these coordinates to determine that negative 18 over 5 is also the same thing as negative 3.6. So my answer for number 3 is the coordinate negative 3.6 and negative 10. Okay, to solve number 4, I'm going to set up my elimination problem in the same way that I did number 3. I'm going to arrange my terms in columns based off the term. So I'm going to have a column of x's, and a column of y's and a column of constants. So this is my first equation. I'll write my second equation underneath, making sure that my variables are lined up. I'm going to eliminate these by adding each column. And I'm going to use the sign that's in front of each coefficient to help me add. So -2 plus 2x is going to eliminate and leave me with 0. Positive 12y plus 1y is going to leave me with 13y. And 15 plus 11 is going to leave me with 26. And to isolate the variable for y, I have to divide by 13 on both sides to get y equals 2. Once I find my y value, I can use my y value to find my x value. I can substitute my y value, which is 2, into one of these equations to solve for the x. So I'm going to rewrite one of these equations, 2x plus y equals 11. And I just picked the second equation because it didn't have a negative and it looked like it would be the easier equation to solve for. But you could have picked the first equation as well. So I'm going to plug in this 2 for y, so 2x plus 2 equals 11. To isolate x, I have to subtract the 2 on both sides, and that leaves me with 2x on the left side, and 11 minus 2 is 9. And then to isolate x, I have to divide by 2 on both sides. And x equals 9 halves, or x equals 4.5, which is the same thing as 9 halves. So now I have my x and y value, and this coordinate is a solution for both equations.